Thank you very much, Shannon, and good morning or afternoon, everyone, from wherever you may be joining me today. So what I prepared for us today is the introduction to what we're calling the world's first information architecture tool. And before I begin the presentation, I like to use this quote. The quote is, "It's a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories instead of theories to suit facts." And this comes from the famous Sir Arthur Conan Doyle, the author of the Sherlock Holmes series. And the reason why I like this quote is it says two things to me. First, it helps me understand why we're focused on information architecture and fundamentally on using information as a high-level corporate business asset. It's this idea that using information to help us make better decisions at every stage of our business processes, every stage of our decision-making cycles, and every stage of our strategic planning. The more information we have available to us from our information systems, the more that we will make decisions that are more accurate, predictable, reliable against what we need to do. What's interesting about this is that the business is going to make decisions whether we give them the facts or not. So our role as information professionals is to provide the best, most accurate, most complete, most reliable facts that we can. But the other reason why I like this quote is it speaks directly about the information architecture itself. The information about the information assets, this metadata that we need to manage, is also going to be critical. And this metadata at business level and at technology level is also going to help us make better decisions about information systems themselves so we can improve the quality, integrity, reliability, and agility of our information architecture system. So it says two things to me. Manage the metadata to better manage the data. Because what we're talking about are some of these key business problems that we're facing. The questions we like to ask is, starting with this idea that first, are you able to react quickly to changes in competition, regulation, or your customers or business stakeholder demands? When changes come, these come from all sources. They come from external sources. They come from things that we need to do to change the way we run our business, even from some of the technologies that we use to implement our business. So change management and change control is going to be key to information architecture success. Are you able to guarantee consistency and accuracy of reports when data is defined differently throughout your entire organization? What this one's talking about is this idea that different business units see different types of information through different colored lenses, if you will. And being able to provide an integrated and federated and reliably accurate report on certain business trends and certain business activities across these silos of information is going to become harder and harder if we don't establish a more enterprise-wide consistent definition. So consistent definitions and standards are going to be key to succeeding in information architecture. Are you able to keep business goals and business intelligence implementations in lockstep? And this is really fundamentally about keeping business intelligence implementations relevant to current business goals. This is when the business needs information and wants information, are our BI systems and our analytic systems providing that information in a way that is consistent with achieving those goals, in a timely manner when it's timely, in an accurate manner when precision is required, in a way that's compliant with laws and regulations. And so this is really in alignment to business requirements and business criteria. And establishing that requirement will be key to success in information architecture. And finally, are we able to demonstrate to management the value of BI investments? Are we constantly begging for investment, begging for money, begging for resources, begging for systems and servers? Or is business investing in it as if it's something they need and use every day? The example I like to give here is no one questions on the executive leadership team, no one questions the value of the elevator that takes them to the executive floor of the building. Nowhere in the planning of any new building has anyone ever said, you know, maybe we don't need an elevator, maybe we'll just take the stairs and save some money. And that's because that elevator is used every day. That's because the value of that elevator in saving time and energy and providing efficiency and security, these values are well understood. We want to provide that same value around business intelligence systems. And what this is about is making sure the information you want is there, that you can count on it when you need to count on it, that it's all there and ready when you need it to be. The system doesn't fail, and the system is always available. When you make it part of business day-to-day process and language, its value, its perceived value will go up, and that's what will pay dividends, and that is what will make the investments happen. So again, making sure that we're in line with the value of the business is going to be key to success in information architecture. So to get there, we need to have a few things. We need to have a clear understanding of our current state environment. Not just do I know my tables in my databases, but do I know how all those different databases relate to each other and where the information is transformed and managed from and to, and ultimately how that relates to what the business definitions are and what those business processes are that manipulate the data. Because we also want to have an ability to respond quickly to changes in both business and in IT. Change management, especially in the analytics world, is a compounding factor. If we think about organizations that have achieved strong, good change management policies, and one example, I was working with an organization that had 3 different mainframe systems from 3 different divisional organizations. And each of those was on a 3-month change cycle, very well controlled, very predictable, very reliable, and in order to ensure business continuity, each mainframe was managed on a different month within the quarter. Now, to the analytics system, that shortened our reaction time down to 3 weeks. So we basically had a week of planning, 3 weeks of reaction for every mainframe change done within a month, because all 3 mainframes federated data to the warehouse. And that didn't take into account, and that the accelerating factor there didn't yet take into account ad hoc changes to Unix-based systems and Windows-based systems that also fed critical information into the analytics environment. So the ability to respond quickly to changes in analytics is compounded even with the best run change management processes in the organization. And ultimately, when we're dealing with responding to change, it's not just knowing where the change is coming from or what impact it has. We also want to have methods to streamline the development and deployment. So once we've identified the change, we've identified the elements that need to be taken into account for that change. How quickly can we roll those out? And how well can we use the existing knowledge of current state system and plan for future state to generate code constructs and code systems that we need to deploy? So Power Designer is evolving to meet those standards. Power Designer first is evolving by providing more business-centric user interfaces to handle the metadata changes. And this is because business metadata to capture the business process, the business definition, business term, at the high level, enterprise-wide, is going to give us that consistency and that alignment that we're looking for to get that lockstep and to get that change management, to get those standards integrated. From there, with Power Designer's new business glossary, we can standardize on business language and then roll that down to all the identifying artifacts that we're going to use in analysis, design, and implementation, conceptual, logical, and physical models. And by using the tools available in Power Designer, we can enforce the different standards and practices at every level through frameworks, through automation. And this ensures that when we come to implementation, and whether we're doing top-down, bottom-up, or middle-out, reverse engineering existing systems and understanding how they relate, ultimately, when we integrate all of that metadata together and have it start to transform and conform to these standards, we'll reduce the dependency on complex integration and federation systems, removing the points of failure and increasing the reliability of the systems, and ultimately also increasing the integrity and the quality of the data. So when we talk about information architecture, and some of the things you may have already started hearing me saying is, we really want to deal with this idea that there's different viewpoints and different perspectives that are going to come together to define and describe current state and future state information architecture. So we need multi-level information architecture design, conceptual data modeling, logical, physical data modeling. And then the physical models are representing the data static, but not data in motion. So we need data movement modeling to understand how all that data flows, where it comes from, where it goes to. And all those models cannot exist in different tools. They need to be fully integrated into the same repository. Because ultimately what we want to do is link the business representations and conceptual models and business models to the application architecture and those logical and physical models. And other models are going to represent the overall capability of the business. Because what we want to be able to do is generate from data to those objects and entities, implement them in various object languages, implement them in XML languages, implement them in database code, but keep track of all those dependencies so we can introduce link and sync, which is a way of saying this business concept became all these physical implementations. It became that web service, that data component, that XML message, and keep them all tied together so that we can understand the impact of change and we can understand all these complex relationships. So as we focus on information architecture, we're talking about fundamentally improving the quality, reliability, integrity, and agility of our data systems, and not just data management, but also analytics. And the reason why I typically don't separate them is today we can no longer manage our data specifically for a project or an application. we need to manage data with an eye towards how it's going to be used in analytics. We have to manage data with an eye towards its secondary uses, with an eye towards its enterprise value, not just its project-centric, workgroup-centric, application-centric value. So fundamentally, if we increase the quality of the data that we're putting into the analytics system by managing it more effectively, we'll have trusted business intelligence, which will be used more. By having fewer points of failure and more integration more seamlessly being performed between the different systems, these systems will be more available, and as they're more available, they'll be used more. And also having more access to more data from more systems to be included more easily into the business intelligence environment, we can improve data integrity. And this is more about completeness. Is the information I'm looking for there? Even if it's there, is it high quality? But also saying, is the information I really want available so I can slice and dice and do my analysis the way I expect? And ultimately, when we have all these things aligned, being able to keep in lockstep with those constant changes, changes in the physical systems, changes in the technology being used, changes in the business requirements and the reports being demanded, changes in the regulation that change what reports are being demanded. If we can keep those in lockstep, the warehouse will never be out of date. And with those 4 key values, business warehouses will be used, business intelligence will be used regularly, investments will be made, the value will be similar to the value of the elevator taking us to the executive floor. So modeling is going to be a key element of this. We talk about modeling, we talk about metadata management, but fundamentally the two must be used together. Modeling and metadata management are hand in glove because modeling provides us, first and foremost, the idea of the visualization of what is there. We have the current state understanding in a graphical form, picture worth 1,000 words. We can define those source definitions. And with those source definitions, we can link them together, and that provides traceability. Traceability ensures that we have the right transformations from source to destination, to MART, to wherever the data is going to be used. And when we've got good source definitions, and we have good traceability, and we have it aligned to good standards, we ultimately have good architecture. That's going to minimize those points of failure, and that's going to give us an easier roadmap for finding problems and fixing them, as well as finding change elements and the impact and managing them. Because ultimately what we want to do is achieve impact analysis. With impact analysis, we can predict the time and cost associated with change, be accurate and reliable in those time and cost associations, which removes risk. All these things come together to give us that agile data warehouse. An agile data warehouse improves business agility and allows us to provide that business value that takes organizations to the next level. So when we look at what Power Designer brings to bear for information architecture, what makes Power Designer unique, is first and foremost, we have all of the different elements needed to handle data management. We have the physical data models, we have the logical data models that define and describe database systems at a technology level. We integrate that with conceptual data models, and that leads us in towards decision support, where we have data movement models, we have requirement models defining what are the requirements for the reports, what are the data systems that need to be tied together, and how we can start looking at data at an enterprise level. And ultimately, that ties into the rest of the enterprise architecture, business process models, application models, XML models, and more, and ultimately the enterprise architecture model. But what this chart also shows us is that these models don't exist as standard standalone elements. That circle in the middle showing this integration lifecycle, what this is telling us is all of these models fully federate together. A conceptual model knows its logical and physical transformations. A physical model knows its conceptual heritage. A conceptual model knows what business processes it's using as its data flow. The process knows the data it's using. The process orchestration model knows its web components and its physical tables. And all these things are stored and managed in the repository. But this chart also shows that we recognize that it's not about putting stuff into models by hand, but it's actually getting the knowledge out of its existing forms. You have existing models and existing tools. You have existing information in Word documents and Visio files and Excel spreadsheets, and we can import all of that. You also have metadata in applications and components and source code. So process orchestration in Bepo for Web Service and WSBePL code. Object-oriented languages and XML schemas can be reversed and generated from Power Designer. Database structures or database engines and catalogs can be read and interpreted, and DDL can be generated back out. So wherever the form is coming from business level documents and office documents to code to other sources, we can bring that metadata in and start to integrate it. Because ultimately, What really makes information architecture work are the intersections between the different viewpoints and perspectives that define and describe the information for the enterprise. If you ever hear John Zachman talk about the Zachman framework, one of the things he says is the architecture is not in the primitive models. It's in the intersections between the primitive models. It's how the information is used by the process and how the process is used by the organization and why the organization is motivated to run those processes. It's tying all those things together that allow us to understand the enterprise and understand its implementation. And Power Designer's unique link and sync technology is fundamentally improving dramatically the way that we capture those dependencies. When models transform from one level to another, we store all the transformation metadata automatically. When one model references another, for example, when I'm defining a business process and a data flow, I automatically link to the data definition in the data model on the flow of the data. It's not a copy, it's not an import-export, it's a dynamic link so that we can trace and track all the business use cases of a given data element, all the data required for a given business process. Tie that to the requirements that define why we want that process and where we want to store that, and use that to transform to logical and physical models to keep everything in sync. Linking that with data movement models for the heritage and lineage at a physical level, and linking that with XML models for canonical data modeling and XML message modeling keeps everything in lockstep. And with the repository capturing all those things automatically, then obviously we can get that rapid response to change, that impact analysis, that gap analysis, and everything we need to plan for change. So our key differentiators for information architecture are fully integrating business modeling with IT modeling at an information perspective. Business process models fully linked to the conceptual data models that define the information at a business level. This gives us that unique single representation of information for all business use cases. So then we partition pieces out into logical and physical models and transform down through those stacks. Not only do we get automated implementation from business concept with our expertise thrown in to refine and develop, but also we have this ability to, and the example I like to give here is thinking about, let's say, customer information. If I think about customer information for the order entry use case, all we care about is name, address, phone number, and method of payment. But when we think about customer, not in order entry, but for customer relationship management, here we actually want to know more. We want to know demographic information. We want to know age range. We want to know ethnicity. We want to know gender. We want to know income bracket. We want to know things about you so that we can build a better relationship with you and offer you goods and services that you would want to hear from us. Obviously, I'm not going to change my order entry process to ask for all of those. So, how old are you when you're buying shoes? We don't care. What we'd like to do is take the information in all these different systems and whatever inputs they're using. But if the common elements like name, address, and phone are standardized, the integration is going to be more seamless. The impedance mismatch between systems will go away. And that's ultimately going to give us a better architected business intelligence environment and a better run enterprise. So Power Designer 16 introduces some new elements, and that's what's really newsworthy about this new release is these new capabilities that looking at this vision, looking at these things that we need to bring to bear, Power Designer 16 is there with everything that you need. So we started with improving the user interface experience, taking an IT tool and making it possible to reduce the complexity for different roles. So now business users and non-architects and non-technologists can use Power Designer in a more comfortable way, unencumbered by the complexity of elements they will not use. Diagram types, tools, menus, toolbars, everything can be completely configured by role, making it easier to allow information architecture to reach out to those non-technical roles and get the information directly from the horse's mouth, so to speak. Specifically around information and enterprise architecture, the Enterprise Glossary, a new global resource to store pure business terms, independent of the data dictionary and the conceptual model, independent of the business process, the logical and the physical models, and allow us to drive the naming standards and conventions used so that we can conform to the core business language. Because in a lot of cases, solving business language problems is the key to solving information problems. Centralizing more around the repository, being able to run impact analysis directly against the repository, and enhancing the portal, which is our web experience, to be able to run different reports and different searches and different analysis directly through the web. Allow more people to participate with this metadata and get more business value from it. And ultimately, the new portal composer giving us an authoring capability through the web, allowing anyone to contribute, to collaborate, and contribute to the modeling effort. For data modelers, of course, at the end of the day, we need to implement systems. So we're continuing our updates to physical data models, tight round-trip engineering for all of the different databases, including new ones. We now have full support for the latest Netezza, latest Oracle, Microsoft, and of course Sybase databases, which includes specialty support for Sybase IQ with our reference architecture wizard. So the next few slides are going to show some screenshots of some of the new capabilities. What I'll do is I'll go through those fairly quickly because I'd like to invest the time in actually demonstrating the tool to you today. So with the new shell and user interface, it's a modern look and feel based off Windows 7. So those who are used to the new Office technologies will be used to the new Power Designer. But with the role-based capability, we can now sub-select different menus and tools and deliver to users only what they need and nothing they don't, cleaning up and clarifying the user interface for those non-technical users while still allowing full power for our power users. Along with this, we've added some new symbol and drawing capabilities to streamline the diagramming aspects because, again, the picture's worth 1,000 words. And the more readable and the more understandable the pictures are, the better they're going to serve as that asset for understanding our architecture. Big changes are being able to edit every aspect of the artifact directly through the diagram, streamlining the ability to create the models, and also being able to include more and more metadata in the graphical symbol so that we can get directly visually the feedback we're looking for, and being able to lay that out side by side, top down, and have these layout controls on how the symbols will show that metadata, give us better readability and better extension of this new capability. Now, not everything has to be text, so we also added the ability to show icons in the symbols representing key metadata. So you can choose which attributes and which fields on a given symbol are going to have an icon associated with it and which icon is used for different values of that symbol. And that way we can, for example, this shows perhaps the sparseness of a given table in a physical model. The employee table is 50% to capacity, where our customers at 100% capacity. To give us a quick idea of where our capacity limits have been reached in a physical model, for example. And last but not least, the ability to now have automatic routing of lines to make sure they don't intersect if they don't have to, and the bridges over lines where they intersect to make it easier to follow more complex models and make sure you're not following the wrong line halfway through your tracing. Now, the business glossary is a great new feature for all users, from data architects to information architects to enterprise architects. What it does is it allows us to capture the business language. We have business terms that can be organized in a hierarchy of folders, which gives us a bit of a classification system over the business terms. Terms can relate to other terms, and terms can have synonyms. Synonyms will be other names for the standard name. Now, once defined in the glossary, as we go to create objects in any model, the naming convention will pick up and provide autocomplete when you start typing the start of one of the glossary terms. You can autocomplete off the glossary. But also, if you start typing one of the synonyms, we will offer you the preferred term for that alternate term as an alternate name. So this allows us to make sure that we conform to the standard business language. And if we discover things are missing or not represented the way we expect, we can now have that business language conversation. Do we interpret and understand each other properly? That will solve those integration problems later on. Repository-based impact analysis allows us to run the impact analysis not just within models in our local workspace, but to leverage the full knowledge of the repository, which means anything that's related to anything I'm dealing with, no matter whether I know about the model or not. The repository is going to be able to feed up that dependency to us. And that allows us to understand the risk of change. And also, when we roll changes out based on these models, that things we didn't expect to break when we roll it into production don't break. The web view is another way of getting access to Power Designer metadata, and the web view is live directly against the repository. So there's no special synchronization or any other mechanism needed, you just connect to the web page with the URL supplied, and you are now looking directly against the repository. Role-based security is still there, so users who don't have access won't be able to see things they're not allowed to see. But with the right access, you will be able to see the relevant metadata. And with Portal Composer, you will be able to edit that metadata directly through the web. So you can update rich text fields, you can update text fields, so you can update comment, description, annotation. And for RTF updates, you can export directly to Word, use the full Microsoft Word editor, and then save and upload that back to the portal. So you can use a full local RTF editor instead of just trying to get text through the web. So it gives you a lot of power in being able to really be expressive in defining, describing, and reach this out to subject matter experts and data stewards and perhaps a host of non-modeling business stakeholders who are contributing to the knowledge about what they do and how they do it to help us build a better IT. And of course, keeping up with all the latest databases, like I said, all the latest in IBM, Microsoft, Oracle, Sybase databases, Netezza databases, and so forth, and making sure that we can still generate and reverse engineer all the physical artifacts of the database, XML in the database, web service in the database, and so on. Anything that's there, security model, grants, permissions, rights, referential integrity, whatever's available in the catalog should be available in the model and vice versa to provide lossless round-trip engineering on the physical systems. Additional new features that we have are the library models. The library models allow us to build reusable content. So this can be either design patterns at the architectural level for CDM or at the design pattern and developer patterns at the logical and physical level. And they're stored in the repository and automatically synchronized. So any use of a library ensures that you're using the latest versions of the libraries as appropriate. We've also improved link and sync capabilities by allowing these shortcuts, which are reused objects between models, to be able to persist even with the target model not open. This allows us a much better readability and better understanding and navigability. And by merging extended dependency and traceability link, this allowed us to have a single kind of dependency link for all artifacts. So we have all the standard dependencies that are modeled from the standard modeling paradigm, and then we have additional dependencies that you can define yourselves. And you can group different types of dependencies. You can create your own list of dependency types and show how those dependency types are relating different artifacts together. This is all part of link and sync and extending our ability to be able to link anything to anything for any reason. Of course, we're also modernizing what environments we support for the latest Windows capabilities, the latest plugins to Eclipse and Visual Studio, and support for the latest Microsoft Office for import and export of documentation. So at this point, what I'd like to do is move over to Power Designer and demonstrate some of these features. So to do that, I will share my desktop. And at this point, you folks should be able to see Power Designer running. What I'm showing right here is the Power Designer 6, the full new user interface. And what you see here is a framework. This has been built using the custom framework editor. For those of you who may have studied enterprise architecture frameworks, this looks similar to something like the Zachman Enterprise Framework. Folks may have studied things like TOGAF, which is more of a free-form flow. We have the ability to draw those kinds of framework diagrams as well. But fundamentally, what this gives me is an ability to put the right models in the right cell, making it easier for me to manage all of the different models and deliverables that will ultimately end up working together. Click on any cell, and it gives you a list of the models that are participating in that cell. We see, for example, in the Enterprise Conceptual Application Architecture, an object-oriented model at an analysis level. But down here on the database level, we have a bunch of physical data models representing a bunch of different databases in my enterprise, a data movement model tying them together, a business warehouse tying them together. So we have a lot of different models at the physical implementation level tied to single models at the higher level. But let's start at the very top. We can capture everything from the business goals and objectives. Remember, one of the things that we're talking about with information architecture is alignment between business and IT. And one of the things we talked about is lockstep with business goals and strategies. So by being able to define the business goals, strategies, and tactics in Power Designer, we can trace them to the various different projects and systems and technologies we're going to derive from that. And from here, for example, we can go into the business requirements. And here we're showing how one goal and strategy document can relate to one or more business requirements documents. The business requirements documents can relate to one or more functional specifications. And through these dependency matrices, we can trace requirement to requirement, or now in this case, a requirement to a process. Now, when we're looking at any given process, for example, here I see that in order to fulfill the stock validation requirement, we're going to need to have some details on the check stock process. Any object in Power Designer that's in any list or grid or dialog box, double-clicking its name will open its property sheet. It'll tell you where to find the object and what its details are. And this button here will take you to the object itself. And then I can read the specification of this business process and look at any other details related to it. Now, this isn't enough for me. What I also want to do is find this in the diagram, so then I can see it in context. So now by being able to see this in context, I can then see what are the flows, what is the rest of the process, and so on. Now what I'm looking at here is a business process model in BPMN notation. And let me just zoom in a little bit and describe a little bit of what we're seeing here. So here, for example, I have a customer. The customer swim lane represents the customer role. And we're going to start, and after we start, we're going to create the order. After customer creates the order, we will then check, is it a corporate kind of order? Because if it is a corporate order, we will handle it following one process flow. And if it's not, we will check a different flow. For example, in this case, telesales will process the order and follow a different flow. Now, the interesting thing is, first we get an understanding of how the business works, but the other is we can use the data on this flow to better understand, do we have the right information to help the business run? So let's go to the Data tab. The data defines what data is on that flow. Here we have customer data, and customer data is defined by an entity in the corporate conceptual model. We can look at its attributes, its identifiers, and so on. Or I can also use this dialog down below to find in the diagram and open the diagram that represents the entity. So here I have a single representation of customer for all business use cases. Every time customer participates on a flow in any business process diagram anywhere in my framework, it's going to relate to the exact same customer entity. The value of that is, as I said before, I can have certain parts of customer defined to fulfill order entries requirements, but then continue to refine that based on CRM requirements and continue to refine that based on inventory control requirements and so on and so forth, until at the end of the day, I have one entity that is the sum of all data required to handle any business process anywhere, and then I can use that as the standard. So when you go to implement your logical and physical systems from this, or when you go to align with existing logical and physical reverse engineered from existing systems, you have an idea of what the rest of this should look like and how you can integrate and federate that back together for master data or for data warehousing or other secondary purposes of the data used in your projects. Now from here, this customer entity has been transformed, and I can use the generated as dependency into a logical entity. This logical entity is in a logical data model, and it has been transformed to a series of tables in a series of different physical models. So I have 4 different tables representing customer data in my enterprise, all related to the same basic customer idea. So this is an interesting point, because when we start looking at real corporate deployments of physical information, at Sybase right now, as a database company, we have over 350 places where we store customer information for one purpose or another. It's not necessarily bad that we have so many places to keep information. What's bad about that is if we don't know about them all, we don't know how they all relate to each other and what they all should be designed by, then they will start to fall out of spec with each other. They'll fall out of synchronization with each other, and ultimately trying to federate that data later for 360-degree customer view, or understanding all the products all our divisions have sold to our customers and being able to provide them a single contract of everything they bought from us and everything we've sold to them, what's on support and what's not, etc., is going to become harder and harder to do and more error-prone and more lossy, and that's not what we want. So having this traceability gives us those connections. But what I promised here is with information architecture is not just having all of these things defined and described, but being able to understand how we can impact and understand the impact of change and manage that change. So while we're here, one of the things I want to look at is, and by the way, with this new user interface, you see I'm closing some of these tabs across the top. These tabs allow us to have all these different models and matrices and diagrams open at once. But to really help us use our real estate, let me just quickly show one of the new things about 16. So I'll open up the conceptual model. I'll open up the business diagram. And then I can tear off these dialogues. And then I can have my process model down here. I can tear this one off. And I have this diagram up here, and I can do better side-by-side viewing. So that's the process, that's the data. I can see them side by side. If I want at any time, I can right-click and redock back as a tabbed window. And this allows me to really, especially if I have a smaller monitor like I'm demonstrating on today, take advantage of that screen real estate. Oh yeah, and by the way, here's one of the other graphical elements we've changed in 16, this arc over the line to show that this item is connected to orders, and this orders is connected to stock clerk. So when lines intersect, we automatically create the jump. When they don't intersect, we take it away. And that just shows some nice usability features that we have. But what I want to do is actually come back to the process diagram and do the walkthrough of our use case. So let's zoom back in on this part of the flow where we have this idea that after I create the order, I check if it's a corporate order. And if I look at the data for this process and look at its definition and its attributes, I see there is no way in my current definition of customer to differentiate between private buyers and corporate buyers. Address, name, phone, that's completely useless. One could argue customer ID can store a combination of customer type and customer number, but we know from proper analysis and design of information that it's not correct to overload a single field with two different meanings. It corrupts the meaning and makes that information harder to integrate later. So what we need is actually a data element that's going to tell us if it's a corporation or not. So I'm going to use company name. Now, because I'm using the same conceptual model for all of my artifacts, I can derive the data details from a standard set of domains. So these are standard named templates for data type, data length, data characteristic, data checks, maximums, minimums, etc. So by picking name from the list, all my names will be alphanumeric 35 everywhere in my organization. So then again, as I conform my implementations either iteratively through change or as I'm building new systems, having them conform to this makes the data easier to integrate and federate later. So those data standards give us a bit of governance and stewardship that we can use. But what I want to show is that even though I made that change through the process model, if I look at the data model, I see very clearly that company name has been added. And that's been only added at the conceptual level. This hasn't changed any of our running systems. So information architecture also tells us we have to take into account the impact of this change on other systems. So I can select this artifact and run an impact analysis. Now, right now, I can run the impact analysis against the systems, the models that we see here. And I can see that there's a set of things that are taken into account. Let me apply a filter, the data lineage analysis filter, that allows us to focus really just on the data transformations. So here we see how I've got the generated entity generating a series of tables. So we have this traceability here. I want to go ahead and click on Use Repository. What this is doing is saying, well, forget about your local workspace. Let's look at the repository and see if the customer entity is actually tied to any other thing. And we see it's picked up a few things, like this business term company name. This artifact was not known. It's got a little blue symbol on it. That was known through looking at the repository. There may be some additional generated objects that were only known because of the repository. And we'll see that little blue symbol showing that. So this means that I've discovered something that I was not taking into account, but the repository knew that connection was there, and we should take that into account. Now, what I'd like to do is actually remove some of the elements that we don't really care about in this particular analysis. We just want to focus on where this is generated to, and I'm also going to add the data flows to this. So now I also want to know, and by the way, everything that I'm doing to change here can be stored as a rule set so that we can rerun this exact analysis anytime we want. And I want to see all the flows that this data is participating on. And again, by using the repository, we can see if there are business processes that we aren't taking into account in our local representation that need to be, and I don't see any. But what this is showing me is that this entity conforms to the customer language defined as the term customer, and I can make sure that it conforms to that definition. has been implemented as an entity with a set of tables, and participates as data on a set of business flows. So any change made to customer, we have to double check all our processes, make sure we haven't invalidated the way data needs to be used by any other part of the business, but also look at all its physical implementations. And then we can generate the diagram, and then we can use this diagram to show stakeholders and management and other people, hey, this is why it's going to take a little bit of time and cost a little money. I need to check all these data flows. I need to check all these physical implementations. And as I continue on, I see that I'm actually implementing further out to data warehouses and data marts. So here I have some joins. I have some links to indexes, taking all the physical artifacts into account. And this is telling me, you've got to take all this into account. You've got to check the indexes, the views, the triggers, the procedures. Now, if we decide we want to go ahead with this change, first of all, we know what our roadmap is. We know the things we need to take into account. We know where they are. We know who's responsible for them because it's all through those models. Let's go ahead and let Power Designer transform this by going from the conceptual to the logical. And with preserved modifications, any work I've done as a data analyst or a DBA to transform that logical model to be the right schema, none of that's going to be touched. Let me turn off the filter. You see when I show all objects, there are other known changes here. There are changes in many different places of this model that are not checked to be taken into account. These are changes that maybe were done to, for example, changing a dependent role to define a relationship further because it's gone to relational versus conceptual. By applying the filter, hide all preservation, show only what's been changed. You see, all we're really doing is publishing a change forward from one model to the other, and now it's there. And then we can make the same change forward by generating through to the physical model. And we can pick any one of these. I'm just going to pick the Oracle one just for grins because that's one of our most popular physical targets with Power Designer. But we also support Microsoft and IBM and a bunch of warehouse databases as well as all the Sybase databases. And again, with preserved modifications, work that was done by a DBA to manage the properties of an index or the physical options on a table or all these other things, none of that's going to be touched. Because when we hide all preservations, the only thing we want to do is add a column to the table. So now the column's added to the table, right-click, SQL preview, and now I can generate the DDL to create that table. By the way, we can also generate change DDL to a drop, add, alter table, add column, drop, recreate the column in the middle of the table and insert data back with data movement language. Whatever is needed to transform the data system into this new database, we can handle. So what we've done is we've basically shown Power Designer being able to handle 3 key values. First, being able to handle business representation, either by importing requirements from Word or Excel, or creating them directly in the tool and linking them together, how business goals can go right to business and functional specifications, but then how they tie to those business processes. From those business processes, we showed the ability to link over to the conceptual model and transform down the stack logical and physical and keep all that in sync. So we've taken a path through a portion of this framework. We could continue to evolve the business process models to process orchestration. We can continue to develop application and technology models and through to their implementation artifacts and keep everything fully synchronized. Now, this is great if you're the modeler, but I also just want to show if you're not the modeler, this is the Power Designer portal. Right now, we're looking at it as the traditional portal, which is a read-only, free viewing technology that comes with any of the repository-based versions of Power Designer. So when you have Power Designer and a repository, you have the repository portal. From here, I can navigate to any artifact in the diagram. You see I've got the zoom in, zoom out. And if you're using Internet Explorer, you'll need an SVG viewer unless you're on Internet Explorer 9. For any other browser, SVG viewing is built in. Click on the artifact, and it takes you to the metadata behind. So it's a fully hyperlinked set of pages served up from the repository directly through this portal. And so now we can take a look, and I can see, this is the customer. And then I can make things now with the portal. Now that I'm looking at it in this view, I've actually entered into the portal composer. I have a license for editing capability through the web. Because you're making changes, this is an author capability and is licensed. I can make changes to the customer comment. and then I can check those in. So since I have permissions, and I have access, and I have a login to the portal, I have a login to the repository, and I have permissions on this object in this model, I can make the changes, and now they're checked in as a new version. So we can always do version compare. Everyone who's on the notification list has been notified that I've made a change, and then they can check that change and accept or reject it through the modeling tool itself. But I can also go to analysis here, and that same impact analysis I showed you in the Power Designer tool is also available through the analysis tab. So now when I run the analysis, I can run a full impact analysis to show, yes, that entity was generated as a logical entity, that was generated as a series of tables, that is linked to a series of artifacts. And these tables here, they may participate in ETL and EII and other data movement technologies, and we can see those through this view here, the target mappings to the source and target warehouses and so on. So full impact analysis live, this gives me the idea of what this thing is, what it's defined as, what it's linked to, what it's related to, all from within a web UI. So fundamentally, Power Designer for Information Architecture gives us three key values: understand, manage, and drive. Understand, reverse engineering, import, get all the documentation in, build the link and sync, and this gives us everything we need to know about our current state enterprise, and as we transform those models, our future state. Manage allows us to use things like impact analysis and comparison reports for gap analysis to understand what's the difference between current state and future state, and given those changed artifacts, what other artifacts are dependent upon that. So I can build the roadmap for change and then use Power Designer to manage that change, which leads us to drive, driving those changes out, driving the implementation from the architecture. And like I said, we understand that top-down is not the real world. We understand through this demo that we showed top-down because it's easy and fast. But reverse engineering is just as easy, and transforming up to logical and conceptual is just as easy, and building these business models out of technology knowledge is just as easy, and then driving that back down through iterations of change ensures that real-world models represent real-world systems, yet keep in lockstep with changes in concept and can re-implement those changes iteratively over time, allowing us to re-architect our enterprise into one that is more, that manages data with better quality, integrity, reliability, and agility. And this is working. Gartner is saying in their latest Magic Quadrant for EA tools that with Power Designer, this is going to appeal to organizations that want a single integrated modeling and metadata solution as part of their core information or enterprise architecture strategies. Those with a strong focus on information architecture in depth will benefit from Power Designer. And this is what makes us unique. When we compare ourselves to other tools in the marketplace, they either don't have these business models fully integrated with the IT models. So traditional data modeling tools don't reach up high enough. But traditional enterprise architecture tools don't go deep enough on information. So really closing these things together is really what's going to provide that value. So at this point, we have some time for some questions. I see that there's been some questions typed into the chat section. So I'll take the opportunity to look at these and provide you some answers on a few. So one I see here is can you explain the XML capabilities while generating XSD from object XML model? How can we specify min occurs, max occurs, etc.? So the best answer to that is if you look at the XML model in Power Designer is a model designed specifically to map one-to-one to XML XSDs. In version 16, we have all of the different artifacts needed to specify the attributes of a given complex type element or element attribute. Min occurs, max occurs, they're simply fields on the property sheet. So let me see if I have a model like that in Power Designer I can quickly show right now. And what I'll do is I'll come back into the sharing for a moment. And so here, for example, we have an XML model. And if we look at the properties, if we look at the detail, we get to specify some of these minimums, maximums. We look at the attributes. In the attributes themselves under detail, we have various fields that we can supply. And here is within these attributes that we would specify the min occurs and max occurs values. So I have another question here. How does the business glossary integrate with the rest of the products other than for naming conventions? Can it be linked to non-Sybase metadata? So right now, the business glossary is integrated into the Power Designer repository, and it will be visible and reportable and can import and export to Excel and can be used as a central clearinghouse for that business glossary and those business terms. Now, as far as using it for controlling naming standards, it will be linked to Power Designer models that are also linked to the repository. So Power Designer models, business models, application models, data models will all be able to synchronize with the glossary for autocomplete, for naming suggestion, for check model compliance. Did you use a name that's not in the glossary, or did you use the naming consistent with the glossary? We have check model for that. For non-Sybase metadata, there's really two choices. One is to export the business glossary in some other form, we can export directly to Excel or to Word doc, and then use it in other formats, import them into other capabilities. Or we can bring non-Sybase metadata through other import means into Power Designer models to be able to establish that link. So now here's another question. We need the business analyst to model data in technology agnostic models and forward engineer to XML. How would Power Designer handle that? So what we're looking at is a logical to XML schema or object model to XML schema. So today what we do is actually the conceptual data model would be used to generate a physical data model, and the physical data model can be used to generate the XML model. So today it's a bit of a round step process, but we would definitely recommend the XML model as the core target model for generation instead of the object-oriented model. The object-oriented model, while not a bad way to represent the artifacts of an XML schema, the object-oriented model imposes an OO paradigm over a hierarchical structure, and that's why we built the XML model. But being able to generate to the physical model and then having the physical model have a transformation over to the XML model allows us to be able to get XML structures physicalized through that process and then tie them back to the conceptual model through the mapping editor. Now I see a few other questions that are coming together. One of them is around how do we compare with the ARIS tool set. Another one is, do we exchange models with products like System Architect and other tools? So there's really two ways to address this question. One is, if you have other tools like ARIS or System Architect or any of the other data modeling or enterprise architecture tools, first and foremost, Power Designer has standard ways of importing and exporting metadata between those tools. We also have a partnership with a company called partnership with a company called Reichmann Informatik. And what Reichmann provides is a set of bridges in their product called Toolbus. And Toolbus allows for a more direct API to API metadata exchange between many popular tools, including System Architect and ARIS. So that's the interoperability answer. The other answer is, how does it compare to some of these tools? Well, first and foremost, Power Designer's link and sync technology is really what makes it different. It's this ability to capture and define and describe all the interdependencies between all of these different viewpoints, all of these levels of abstraction, all of these perspectives that give Power Designer the edge in being able to capture and manage architectural metadata or architectural knowledge. When you use something like ARIS and focus on process, or use something like System Architect and focus only on architecture, or use tools like Irwin and Embarcadero and focus only on data, you're leaving pieces of the picture out. And integrating these tools with manual bridges and other capabilities, all it does is exacerbate the problem and throw manual process into a place where automation could be. And that's really what makes Power Designer different. We have all the tools, we have all the models, but we integrate them all together in a unique way that manage to capture those dependencies for you that get the job done. So I think I have time maybe to capture one more question. And so one last question I think I'll address is, one of the questions here is, do you also support the Greenplum database? So what's interesting about databases like Greenplum is, as they're gaining in popularity, we will certainly be looking to support them. But what Power Designer offers is two advantages. One is, no matter what database you're looking for support on, PowerDesigner has generic ways of being able to interface with them using a ANSI standard SQL interface and ODBC connection. You can reverse engineer just about any database that's available today, even non-relational databases that have an ODBC driver providing a kind of relational catalog on top of flat files or other structures. And that's the simple answer. The other answer is PowerDesigner's database definition is fully extensible and fully open and configurable. And what we started doing with some of our Greenplum customers is capturing some of the core capabilities that are unique to Greenplum and extending the database definitions directly in the tool. It's a nice GUI that allows you to define what queries are run against the catalog to reverse, when templates are used for physical options and data types and other things to generate. And in a few very short interactions with the XDB editor, we've created some extensions that will support Greenplum capabilities. As we move forward, we'll obviously be productizing those. But what this means is if your database is not on the list, that doesn't mean that there's no way for us to support it. It just means that out of box, there's no direct full support, but there are ways for us to be able to support your environment. So Greenplum is one that's up and coming, but others are perhaps are legacy and old and not supported or are homemade. All of these things can be configured with PowerDesigner. So thank you very much for coming. If you folks want to learn more, what you can do is the best thing for you to do is schedule a customized demo. If we know exactly what your environment is and exactly what your challenges are, we can deliver to you a demonstration of the product that's fit to purpose for your needs. And that will dramatically improve your evaluation experience. Also, certainly feel free to contact us at any time, 1-800-8-SciBase. Press 1 for the sales option. Let folks know you want to schedule a customized demo. And if you're not in North America and the 800 number is not working, simply look at our global offices. Find a local office close to you and give them a call. They'll be happy to help you out. And you can also read and research more about PowerDesigner and PowerDesigner specifically for information architecture on our information architecture page at scibase.com/IA. We have analyst papers, technical white papers, on-demand webcasts, and more. And this is a great way for you to learn and read and understand PowerDesigner more. And from there, you'll also be able to find evaluation versions of the product that you can try yourself. By the way, if you need more than the 15 days of evaluation time provided, certainly, again, contact sales, and they can give you an extended trial to help you complete your proof of concept. And at that same time, perhaps even offer you some assistance in making sure that what you're seeing is meeting your needs. Thank you very much for joining us, and certainly don't hesitate to visit us at scibase.com/PowerDesigner.